All right, but let's go on to health monitoring. Okay, so in health monitoring, we set that up in Octopus, and in Azure, I'm just going to pop over to the Azure portal real quick. Let's see here. We have quite a few resources in here, but if I took this sample, I broke it and I fixed it, and let's see, last 4 hours. There we go. We had some failures. We had some successes. Okay. Ultimately, you want it to look like this. Last 30 minutes, always successful, 22 counts, and the availability test, you just choose what regions you want to do your monitoring from. Okay. There's lots of IT tools that'll do your ping test. Basically, this is Azure's version of a resource that's just going to check for availability. Okay? And it's part of Azure Application Insights, and it is an availability test. So that's what to look for. This is not a tutorial for how to set up that in Azure. There's lots of documentation. It's not that hard. But effectively, we just add an availability test, and I'm going to click on the pencil for edit, and it's very simple. Hey, what is the URL for me to check? You just paste in the URL. I mean, you could check google.com if you wanted to, and you select a test frequency. You select how many locations around the world you want the test to be run from, and then what's the success criteria. And whatever if all you care about is it succeeding, that's great. And then you can just save it. Now, in the case of the health check, all you care about is that it doesn't blow up on you. And the health check is really great because if it returns unhealthy, you're actually getting you're not getting the HTTP 200, okay, which is good. So it helps with those HTTP status codes. You don't have to look for a magic word. All right. So for health monitoring, now every 5 minutes, we're actually calling our health check endpoint from multiple regions around the world, well, the ones that I care about. Okay. That's going to be different for every one of you. It might be only one region. Who knows? So every 5 minutes, we're making sure that we're up. Now, most of the time, these tools just make sure that the web server is responding. But because we wired it up to our health check endpoint, and we have health check classes in our code base for every one of the application's dependencies, we actually get a very rich, deep answer to the question of, is my application actually healthy? Because we're cascading that URL ping to the database, to Twilio, to Azure Service Bus, to whatever credit card merchant, to all the different dependencies that your application actually makes use of. You've created a health check class with just a couple lines of code that does a quick round trip just to make sure that we're online, that we can reach that service, and everything was deployed with the correct keys poked into the right configuration files, and that nothing happened at any point in time to mess something up. And with this is what you're going to find. You're going to get back some situations where, like, for a 1 or 2 minute period of time in the day, one of your dependent services was offline and that code failed. And now you have an unhealthy return. You're like, how did an application go unhealthy? It happens. It happens all the time. I mean, try integrating with PayPal. Those web services, and it's like, oh, I got an error. Oh, I got an error. And then they come out, oh, and what's their answer? Oh, I'll just retry. So you're gonna have that. But you start to learn the nature of the other services that you've chosen to integrate with, and then you start putting in some code, expecting it to fail and deciding what to do if it fails. And maybe you want to do an instant retry if it fails. And then if it fails twice, you want to kind of fall back and put that request in a queue, and we'll charge their credit card, based on a queue. And once you've done some compensating logic, you can change your health check from unhealthy to degraded, because the application as a whole is degraded because one of the dependencies is not online, but you have code that compensates, that doesn't cause your whole application to be in an unhealthy state just because one of your dependencies was in an unhealthy state. So let me show you that again. In our 64-bit, we can choose to give it a degraded status. Okay. So we can choose healthy, unhealthy, or degraded. And if you have compensating logic where your application can still continue to function even though one of the dependencies is unhealthy, well, now you can report this degraded status, and ultimately you'll learn about why all of your dependencies might have little blips. You'll figure out the compensating code in your integration to make your application resilient to those instability blips of the services that you integrate with. And then that'll make your application more resilient. So no matter what happens with these other dependencies, your application knows how to handle it temporarily and can continue on in a degraded status instead of immediately going to unhealthy. Because if you're immediately unhealthy and someone clicks on a button that tries to go to PayPal and PayPal's acting wonky right now, well, you have no choice but to give your user an error. Hey, you can't do that right now. Whereas once you've learned PayPal, well, maybe, we can take your order. I couldn't immediately hit PayPal, but let me just take your order. Let me take that. Let me drop it into an Azure Service Bus queue. Let me give you your confirmation code that we received your order. And maybe the logic is that we'll send you an email once we do successfully charge your credit card through the merchant service or whatever it happens to be. So these are things that are integrated with health checks to make your application more resilient as you learn your computing ecosystem over time.